Welcome to MAC 1105. This is college algebra. We're going to start off this course by reviewing some of the algebraic procedures and concepts that you should already be very familiar with. And that's what Module 1, or what I'm calling Module 1, Chapter 2 in your textbook is all about. The first thing in this lesson is about solving linear equations. I'm going to go through this very quickly because, as I said, this is something you should know how to do and you should be pretty proficient at it by now. So let's see what we would do if we have a linear equation. Remember, it has an equal sign. The first thing we do is distribute multiplication on both sides. Well, over here we have 9x, and we'll distribute this negative 5. And negative 5 times x will give us negative 5x. Negative 5 times negative 3 is going to give me a positive 15. And on the right, I have nothing to do. And then I'm going to combine like terms on each side. So I have negative 9x minus 5. Positive 9x minus 5x gives me a 4x. And then I have this positive 15 over here. And that's going to be equal to 27. And the last thing I need to do, or the next thing, is let's get this variable term isolated by subtracting 15 from both sides. Now, when I do that, of course, it goes away over here on the left, so I just have 4x. And on the right, I'm going to say 27 minus 15, which would give me 12. Final step, and this is the only time we really divide when we're doing this, is we will divide both by the coefficient of the variable term. I divide by 4, I end up with just x. I divide the right by 4, I end up with 3, and x is equal to 3. Let's take another one and look at it. Number 2 says, it has a few more things to distribute. The hardest part about this is we have to distribute a negative. We're taking this negative 2 and multiplying it times each term inside parentheses. So don't forget, distributing the negative is sometimes where we make our mistakes. We're going to say 4x. We'll distribute the negative 2, and that's going to be a negative 2x. Distribute the negative 2 again. Say negative 2 times positive 7 gives me a negative 14. And then that's going to equal, I have to distribute a positive 2 over on the right. So I'll say 2 times x, and then I'll say 2 times negative 6. So I'm getting closer. I'm going to combine like terms. Well, over on the left, I have some x terms that are alike. So I'll say 4x minus 2x gives me 2x. And that negative 14 is not like anything else. So for simplicity's sake, or for clarification, I'm just going to keep writing it down. Now I have 2x on both sides. I usually get my variables together first. But look at this equation carefully. 2x minus 14 is equal to 2x minus 12. The only thing different is the minus 12 and the minus 14. And those cannot be equal to each other, so this can never be a true statement. But let's go ahead and simplify, or keep on solving by doing what we usually do. Let's subtract 2x from both sides. When I subtract 2x, they go away. 2x minus 2x is 0. 2x over here minus 2x is 0. What do I have? I have negative 14 is equal to a negative 12, which we know is never true. And if we hit that situation where our variable term disappears and we have a false mathematical statement, we say there is no solution. There is no real number that will satisfy that equation, so there's no solution to it. Let's take a look at number 3. We'll distribute the 3 first. 3 times x is going to give us 3x. 3 times negative 5, negative 15. And then I'm just going to have a plus 8 over here that just has to come down. Let me just bring down the right side because I didn't have any work to do there. Now on the left, I'm going to combine a negative 15 and a positive 8. When I do that, I have 3x. This is going to be a minus 7. We add them together and keep the sign, subtract them and keep the sign when they're opposite signs, right? So what I have here is 3x minus 7 is equal to 3x minus 7. At that point, it looks like they're identical. Both sides of the equation are identical. Let's go ahead and get rid of the 3x by saying I'll subtract 3x here and subtract 3x here. I end up with negative 7 is equal to negative 7, which that's a true statement. I'm okay with that. So my solution is all real numbers. In other words, everything works. So case 2 and case 3, keep in mind, if you solve the equation, the x variables disappear on you, and you have a false statement, there's no solution. You have a true statement, it's all real numbers. Now let's look at fractions. Whenever you have an equation that has fractions in it, what you want to do first is clear the fractions. You look at the equations or the fractions and you try to come up with the least common denominator. Well, 4, 4, and 3, the smallest thing they will all three divide into is the number 12. So I've got an LCD of 12, and I'm going to clear these fractions. I'm going to get rid of them. I'm going to put some parentheses out here to show that I'm going to multiply everything. Each term inside those parentheses, I'm going to multiply it times the number 12. This is, in effect, the same thing as multiplying both sides of the equation by the same number. So when I say 12 times, and really all I'm wanting to do is, I'm going to go ahead and cross-reduce. I would cross-reduce the 12 and the 4, and it would end up being a 3. So I'm really going to say this would be 3 times that 64 minus 5x, right? Okay, that's on the right, left. Now let's see, I'm going to do the same thing with this second term, and it's going to say cross-reduce, and 4 divides into 12 3 times, so I'll say 3 times, this time it's times 7x. And I'm going to go ahead and put my sign down or my operation down, and then I'm going to say cross-reduce here, I'm going to end up with 4 left over, so I'll say 4 times 2x plus 1. Now at that point, I've got some work to do, but I don't have any more fractions. And that is your goal. Find an LCD, multiply every term in the equation by that LCD, and you will have no more fractions. If you do have fractions, you've done something wrong. So now let's see if we can simplify this even further. We'll take and distribute this 3 first. 3 times 64. I'd use a calculator if I were you for some of this. That's 192. And 3 times negative 5x. And over here I've got 3 times 7x. And then I'm going to say negative 4 times 2x. And negative 4 times 1. All right, simpler still. Let's see, nothing to simplify on the left-hand side, but over on the right, I have some work to do. I'm just going to write this down, and I'll say 21x minus 8x. 21x minus 8x, I get 13x out of that, and minus 4. Now I'm ready to get the x variables on the same side. I choose to work with the smaller one so that I don't end up dividing by -1 at the end of the solution. And the smaller one, of course, is the negative 15. It's smaller than the positive 13. So I will add 15x. Now I'm just going to write it down because I'm doing all this in one step. If I add 15x here, I'm going to add 15x here. Now when I do that, these are going to disappear. So what I really want to do is get this negative 4 to go to the other side. Well, I'll add 4. So now the 4s would disappear over here. The x's are going to disappear over here. I have 192 plus 4, 196. And over here, I have 15x plus 13x would give me 28x. I take my calculator and divide both of these by 28, and I find that x is equal to 7. To check, you would plug these back into the original equation and see if you came up with a true statement, okay? Let's look at the next set here I've got. If I can get past the wire that's messing me up. Okay, the next one, number 5, is also fractions, but these are rational equations. Variables are in the denominator. Look, my variables are down here in the denominator. Now, this means that I really won't know when I find a solution, I'm going to have to check that solution to make sure it doesn't cause a 0 in the denominator, right? So keep that in mind when you end up with fractions with variables in the denominator, or rational equations with variables in the denominator. But what we've got to do is say we need a common denominator. X plus 2, x minus 4, well, I'm going to have to treat those as single terms, so I'll put them in parentheses. And I'm going to see if either one of those is a factor of x squared minus 2x minus 8. So I'll try to factor that. First, I know because this is a negative sign, I'm going to say one of them is going to be x plus, the other one's going to be x minus. I'm looking for factors of 8 that will subtract to give me a negative 2. Well, what about 4 and 2 would subtract? If I had a negative 4 and a positive 2, I would get a negative 2 when I subtracted. Let's check it. X times x is x squared. 2 times negative 4 is negative 8. I've got 2x for inside, negative 4x. That combines to give me a negative 2x. So I'm going to draw a line through here. I've replaced that denominator with x plus 2 times x minus 4, which is exactly my other two denominators. So what is my least common denominator for these? it's going to be x plus 2 times x minus 4. All right, so now I want to multiply everything, every term in this equation times that least common denominator. So I'm going to multiply it times x plus 2 times x minus 4, and I'll put it over the number 1, because remember, my goal here is to cross-reduce and not to multiply everything, but just cross-reduce it first, and then whatever's left over, I'll multiply times the numerator. So when I do it times the first term, I see these x plus 2 in the denominator and the numerator, so I'm going to have 5 times just x minus 4. And that's going to be plus a 2 times, same thing happened, the x minus 4 is canceled. What's left? X plus 2. And that's going to equal 30 times, well, this time both of these terms will cancel, so it's just going to be 30. They cancel, they become 1s, right? So now I've got a simple equation to solve. I say 5 times x, 5 times negative 4, and then I say 2 times x and 2 times 2, and all that's equal to 30. Let's get our like terms together. I've got a 5x and a negative and a 2x. That gives me 7x. I've got, and I like to do this when I've got a negative 20 and a positive 4, right? So that's going to give me negative 16 is equal to 30. When I get rid of this negative 16, I need to isolate the variable term, so I have to add 16 to both sides. I'll end up with 46 over here. And that means that x is going to equal 46 over 7. Now, I've got to think about that a minute. 46 and 7, do they have any common factors? I mean, could you divide 46 by 7? If you aren't really familiar with your multiplication division tables, it's going to hurt you in this class. I would brush up on it. But 46 and 7 don't really have any common factors. The only one they could have is 7 because that's prime. So I can't reduce this fraction. So I'm going to leave it as it is, 46 over 7. No need to change it to a decimal. And I look back at the equation, I say if x was 46 over 7, it would not cause a problem with any of my denominators, would it? Nothing would be a denominator of 0. The problem here would be if x was negative 2 or if x was a positive 4. That's when it's going to have trouble, but it's not. It's 46 over 7. So that's going to be fine. That looks like a good solution. Next, let's do another one sort of like that. We have a denominator of 2x minus 1. And x, and another 2x minus 1. Now, it's tempting to say the LCD is 2x minus 1, but it's not. Because we've got an extra x in there that we cannot factor out of 2x minus 1, can we? So we're going to have to say our LCD is combining both of those. It's x times 2x minus 1. If this had been 2x minus x, we would factor that x out, and we would say that was our least common denominator, but it's not. I hope you see the difference. So I'm going to multiply each term times what I have determined to be my least common denominator, which is x times 2x minus 1 over 1. Now when I multiply it times the first term, I can see that the 2x minus 1s will cancel, and I'm going to be saying 2x times x. And next I'm going to say this is going to be the x's cancel, right? And it's going to be 1 times 2x minus 1, which is really just 2x minus 1. And then the next time what's going to happen is the 2x minus 1s are going to cancel, and I'm going to be multiplying 1 times x. So to simplify that, 2x squared plus 2x minus 1 is equal to x. Well, now we got x's on both sides, and that'll never do. So let's get this x to go over here to the other side by subtracting it. I have 2x squared. When I subtract this x, I say 2x minus x, and that gives me just plain old 1x, right? And now it's equal to 0. Now remember how we can find solutions for quadratics, which is this term is squared, right? So we can find a solution for x if we factor. And if we can come up with factors, let's see if we can. And this is does not look like a hard one. I've got the negative sign says I'm going to have an x plus for one of the terms and an x minus for the other one. And you might be able to just see this one in your head, but if you don't, I've got a method that I used in intermediate algebra teaching, and I'll keep using it this time for those of you who took intermediate with me. And what it is it's the a times c, which is saying multiply the coefficient of the a term times the c term. So I'm going to say 2 times -1 gives me a -2. And down here we got the b term. So what's the coefficient of the b term? It's 1. In the sides of our diamond, this is really a diamond method, we're going to put whatever the coefficient is of the a term and times x. So we'll put 2x. And then there's our signs, one of each, right? So I've kind of just built my solution here so I can test out the solutions. I want factors of -2 that are going to combine to give me 1. Well, okay, so 2 and 1, right? One of them has to be positive and one negative. So I really want the bigger one to be positive. I want it to be a +2 and a -1. 2 minus 1 to get to 1. Now, when I do this, I see that this is written as a fraction on purpose so that if these reduce, we reduce them. This is really x plus 1. That's my first factor. The second one is 2x minus 1. Now, if this is new to you and you have another method you love to factor and you're very proficient at it, that's great. If you are not proficient at factoring, you can look up this method or call me or ask me for more detailed. I've got some other videos I can give you if you want to get better at it, but you got to get better at it fast because we have to move on in this class. Now let's set each of these factors, binomials, equal to 0 and solve, and we will have two possible solutions, which because these have they're rational expressions with variables in the denominator, we got to check and see if any of them cause division by 0. So I got x plus 1, I'll subtract 1 from both sides. X could be -1. And over here, well, first let's get the 1 to the other side, and then we'll divide by 2. X could be 1/2, right? So what happens if x is a -1? Well, if x is a -1, and you would probably write this down and check it, but I'm going to show you really quickly, then I would have -2 minus 1. That is not a 0, is it? Over here, I would have -1. This one is a good solution. I'm going to circle it. What happens if x is 1/2? Well, if x is 1/2, 2 times 1/2 is 1. 1 minus 1 is 0. This one, as soon as I found the first division by 0, I realize it cannot be a solution, and I cross it out. Now let's take a look at page 2, and it's talking about solving what we call literal equations. And that is, and I've given you a lot of notes on these pages. You might want to read, make sure you read through them, make flashcards if there are things that you need to study, because there's going to be a lot of memorization procedures and terms in this class. So keep in mind that these are there for you to get the information you need to memorize. So what is a literal equation? Well, how do we solve it? It tells you, locate the variable you're asked to solve for. If they're fractions, you're going to multiply by the LCD to clear the fractions. Then you're going to get that term that has the variable all by itself on one side, and then you're going to isolate it if you have to by dividing. Now, this term that we are asked to solve for is n. And n is over here on the right, but it's in the numerator and the denominator. So the second step, so it says locate it. We did locate it. Now let's get rid of our denominators by multiplying times the LCD. And for this one, the LCD has to be just that denominator because we don't have but one fraction. So it's r plus n times r. And the little r does make a difference. It's different. It's not the same as capital R, okay? So first I'm going to take and get rid of the denominator by multiplying everything times r plus nr over 1. And when I do that, over here I'll do the first side. This side I'm going to end up with I times r plus nr, right? And that's going to equal, now these are going to cross reduce, so it's going to equal just the numerator, which is n times e. Now, what do I do next? Well, let's distribute multiplication. We end up with I times r plus I times n times r, and that's equal to n times e. Now, let's see what we can do here. The next step, I really have an n in both of, I have an I in both of these terms. I'm trying to decide, how I can simplify this the best way. And what I would do normally is I would get rid of everything on one side except the variable term. Well, over here, I mean, I've got a variable n and I've got a variable n. I need to get the n's on the same side, don't I? So that's what I'm going to do next. I'm going to take this and subtract INR over here. And I don't usually write these down for you, but I'm going to do it because these are literal equations and they're sometimes confusing. So what's left on the left is just IR. It's equal to n times E minus I times n times R. Okay, I did get the n that I'm solving for over on the left. Now, it's stuck in the middle of two terms, but I can factor it out, right? If it's in both terms, I can factor. Let's see if I can factor and see what happens when I do that. I'll bring out the n and say that's equal to n times E minus IR. Well, good, I got it isolated that way, didn't I? Now, I just want it to be all by itself on this right-hand side, so I've got to get rid of something that it's multiplied by, which is E minus IR, right? Oops, IR. Okay, so if I divide by E minus IR, I have to divide by E minus IR. And when I do that, I can say, okay, now I have n isolated. So whatever I have over here on the left is the solution, isn't it? And what is it? Well, it's I times R over E minus I times R. And that is my solution. Now note that you can't reduce these IRs here because these two terms in the denominator are not multiplied. If they were multiplied times each other, you could reduce. But since that's subtraction, addition and subtraction, we're stuck with them. So there is my solution. N is equal to I times R divided by E minus I times R. Let's look at another problem that's considered one of a popular word problem because it talks about the sum of three consecutive numbers. Now, when we have, and you have to interpret, you're going to use one variable if you can. For instance, we want just X variables in it because we can solve for one unknown. So I'm going to say the first number is going to be, I'll make the first number, I'm going to make that X. So the second number, what do I know about it? Well, I know that it's one more than X, right? Consecutive, so that would be X plus 1. And the third number, I pretty much know that that has to be X plus 1, right? One more than that one, so that'd be X plus 2. And I know that if you add these three together, because it says the sum of them is, that means equals, right? So I'll sum them and make it equal to 330. So X plus 1 plus X plus 2 is going to equal 330. Now it's a simple equation to solve. How many X's? Well, I've got 3 X's. And I've got 1 plus 2, which is 3. And that's equal to 330. Subtract 3 from both sides. I'll have 3x is equal to 327. And when I divide both sides by 3, I get that my first number, x, is equal to 109. That's the first number, isn't it? Well, the second number is x plus 1, which is going to be 110. And the third number is x plus 2, which is going to be 111. So my three numbers, consecutive numbers, are 109, 110, and 111. Now the next page has a bunch of notes at the top that I've given you from it's from another class, but if you're translating problems, if you're translating word problems, you need to know what certain words mean. These words under this first column over here mean add, and these words mean subtract. Then we have words that mean multiplication, division, and equals. When you see these words, we want to put an equal sign. A lot of times you can do what I call straight translation with a word problem. Just insert the mathematical symbol in place of the word, and you will have your equation that you need to solve. This first one, though, is a little bit different. It is considered a change of, it's a percent of increase problem is what it is. Now we have percent of increase and percent of decrease. And what that means is that the original number is going to be increased by a certain amount or decreased by a certain amount to get the final number. And any one of those three things could be your unknown. Your original number could be unknown. Your percentage that you're decreasing or increasing by could be unknown. The final amount could be unknown. And in this case, the hardest one to solve is always when the original is the unknown, and we really need to think about our equation, which is the original, and we would add to that the percent, which is going to be the rate, times that original amount, and it's going to equal the final amount. Now, I would definitely memorize this equation, okay? You'll see later we'll do a percent of decrease. It'll be the same thing, except we'll just put a minus here. So this we think about for sales tax. I take the original amount of the product, and I multiply that amount times a certain percentage, add it back to the original, and that's how much you finally pay. So this is easy to do. If you know the original and the percent, it's easy to get the final. If you know the final and the percent, you've got to do some backtracking to get to the original, and that's why the equation comes in handy. So let's replace what the problem tells us in the equation and see what we find. This says including an 8% sales tax. That's my percentage, right? I'm going to go ahead and put these two down. So 8% would be 0.08. Don't ever do multiplication or math with a percent. A 0.08 sales tax in an N, they charge $151.29. Now that includes the tax. So that is what they charge. The final thing that they charge is $151.20. And then it says find the nightly cost before tax. In other words, find the original amount. So X is the original. This is multiplied times, so I'll just put it right next to it, okay? So what I've got is X plus 0.08X is equal to 151.20. Now I just have to combine my X's. I'll add them together. This is 1X, isn't it? 1 plus 0.08 is 1.08, and that's going to equal 151.20. To get my answer, I'll divide both sides by 1.08. Calculators do come in handy. And I end up with the room rate. The rate that they charge is $140. Tax added, it comes out to $151.20. Now, let's do another one that's sort of kind of like these, or a little bit like it. Let's look at the average yearly salary of a person whose final degree is a master's and then whose final degree is a bachelor's, and they've given us the relationship between those two degrees. Let's see what they say. It says if we suppose the average yearly salary of an individual whose final degree is a master's is $46,000 less than twice that of the individual whose final degree is a bachelor's. Well, here's the thing. They told us nothing about this bachelor's degree. So I'm going to make it X because I know nothing else about it. A bachelor's salary, I'm going to say that's going to be my unknown. A master's salary is the other thing I've got to figure out. And I want to write it in the same terms as X, right? It's the same terms as the bachelor. So what do they tell me? 46,000 less than twice. Now, less than, when we look at less than, it means subtraction, but it's one of those you probably ought to put a star by because it translates backwards. Less than translates backwards. So I have to say, instead of saying X minus 46, what I say is instead of saying 46 minus X, I say X minus 46, okay? Less than twice. Okay, so less than twice that of the bachelor's, there's twice the bachelor's, and minus 46 would be 46 less than twice the bachelor's. So you kind of go back over and check it and see if you got it right. Then what did they tell us? Well, they told us that if we combined these two, combined would say add them together, right? It'll be 125,000. So X plus the 2X minus 46, no need to put it in parentheses if I'm not distributing anything, is equal to 125. Simple equation now. Combine the X's. Add 46 to both sides. You're going to get 125 plus 46 is 171. And divide both sides by 3. And you're going to find that X is equal to 57. 57 what? Well, everything was written in this problem was talking about thousands. That's why I didn't write out all those zeros, because everything was in the same terms. We can say, well, 57,000, and you know that K means thousand. So it's $57,000 is the bachelor's, isn't it? So what's the master's salary? It's going to be 2X minus 46. That's going to equal 2 times 57. minus 46, and you can do that with your calculator easily enough and come up with 68, once again, thousands of dollars, right? So I've got $57,000 and $68,000 should be my two salaries. Now next, we're choosing between two health clubs. Club A has membership fees of $16 a month, and $16 is the fee for membership, and then you got a monthly fee of $11. And Club B has a membership fee of $28 plus a monthly fee of $8. So how much are they going to cost? How much would they? How many months would it take for them to both be equal to each other? In other words, how many months would you have to pay for them before you would say, well, these sort of balanced each other out? Let's look and see. Write it down what we have. Club A. I know the Club A cost, don't I? It's going to be $16 plus a monthly fee. Well, we're looking at how many months, so we'll call the number of months X. And each month we'll have to multiply that times $11. So it's $16 to start plus $11 times the number of months. Club B. They are a little different. They start with an enrollment fee of $28, and then they only charge $8 a month. So how do I find out how many months, which I let how many months be X, didn't I? They would be the same. Well, let's just set them equal to each other and solve for X. All right, I need my X's to be on the same side. I'll start with the smaller one. Subtract 8X over here. Subtract 8X over here is 11 minus 8. That gives me 3X. That means I want to get rid of the 16, so I'll subtract 16 from this side. 28 minus 16 gives me 12. Divide both sides by 3, and I get X is equal to 4. Those are months, right? So in 4 months, you would be paying exactly the same thing for membership at these two clubs. Now our next problem is the one I sort of warned you about or told you about. This is going to be taking a percentage and seeing what happens when we actually decrease by a certain percentage. In other words, what happens when you put something on sale and you know that you purchased the total purchase price was $198, which is what this washing machine is, but that was after the 70% was taken off. What did it cost before that? Now, because that is after that 70% has been taken off, you can't multiply 70% times that final amount and add it back in. It won't work. We have to go back and say, I know my formula. Original, this time it's a percent of decrease minus the percent that's decreased, which is the percent times the original. And that's going to equal the final amount. It's an easy formula, so memorize this formula, okay? All right, so I've got the original amount that I don't know. Once again, but I do know the decrease percentage is 70%, which is 0.7 times that original amount, which is X. And I know the final amount was $198. What was the original amount in this thing? Oh, that's supposed to be minus, sorry. So I've got 1 minus 0.7, don't I? 1 minus 0.7 is 0.3X is equal to 198. When I divide both sides by 0.3, I find that X is equal to 660 in the terms of the problem, $660. So the machine costs $660 after 70% was removed from that 660. They sold it to me for $198. Next, let's look at the length of a rectangular playing field. It is 4 yards longer than triple the width, and they are giving us the perimeter. Now, you know the formula perimeter. Perimeter is equal to 2 times the length plus 2 times the width, right? That's the formula that you've known forever. So we've got a rectangular field, and the length is 4 yards longer than triple the width. Well, they tell me about the length, but they don't tell me much about the width. They don't tell me anything. So I'm going to make the width, and I'll say W, cursive W, is equal to X, okay? That's going to be my width is X. So can I represent my length in terms of X? What did they say it was? Well, they said it was 4 yards longer than, so that's 4 yards added to it. Triple the width would be 3 times X. So now I've got the width and the length. I know that 2 times the length plus 2 times the width is equal to the perimeter, right? So let's say 2 times the length of this thing is going to be 2 times 4 plus 3x. Plus 2 times the width is going to be 2x. It's equal to the perimeter, which they gave to me as 344 yards. So let's distribute multiplication. We have 8 plus 6x plus 2x is equal to 344. And that, of course, is going to be 8 plus 8x, isn't it? And then if I get I want to isolate that variable, I'll have to subtract 8 over here. So I'll say 344 minus 8. I'll subtract it over here, and I get 336. And I'm going to divide both sides by 8. So x is going to equal 336 divided by 8. I get 42. Okay, x is the width, isn't it? So what is the length? Well, the length was 4 plus 3 times the width. In other words, it's going to be 4 plus 3 times 42. Easy enough to type that into your calculator, and you come up with 130.